How's it going today, guys? Today we're going to be talking about algebra properties. Specifically in this video, the properties of multiplication. If you can recognize your properties of multiplication and how to use them, you can definitely recognize and use properties of addition. They're very closely linked. The purpose of properties is to be able to solve equations a little easier. They make you move numbers around, be able to solve certain parts of equations first that might be preferable, right, in order for you to solve something easier. So we're going to go through a couple examples right now of what that looks like so we can understand why they're important. And then we'll go through a couple just example problems of identifying them. Okay, so speaking of identifying, here's the first property we're going to talk about, the identity property. Okay, this is a pretty easy one, pretty basic, nothing too crazy. All it means is a number. So if we have like 13 times 1, we know it equals 13, right? If we have something like 26 times 1, we know it's 26. That's all there is to it. The identity property I like to think of as the identity does not change, right? We know 13 times 1 is 13. 26 times 1, 26. I do want us to keep in mind you can also flip which side of the equal sign that the equation goes on. So we could also do something like this. We could say 14 equals 14 times 1, right? It's not important, or it does not matter if, you know, what we call maybe the answer goes on one side or the other. It's just saying that this is equal to this, right? This is equal to this. This is equal to this, okay? So that's the identity property. Pretty straightforward, nothing crazy there. The next thing we'll talk about is the commutative property, okay? Commutative property is used to move numbers around in equations. So we could see in this, example using letters or variables, we go a times b is the same as b times a. So a time when this might be handy is when I say, okay, well, 2 times 17 times 5. Okay? We can use 3 numbers instead of 2. Equals. So now I want you guys to think about, it's not really the easiest thing to go 2 times 17 times 5 and get an answer, right? How could I rearrange these numbers, or what order would you rather multiply them in to make it easier? If you want to pause and try and figure that out for yourself, take a guess at it, go ahead and pause the video, try that. I'm going to go ahead and do it right now. I'm going to say what I would rather do is do 2 times 5 times 17. And that won't change my answer, right? Whether I multiply in order right across or change the order, it won't change my answer. So I'm going to say this is the same as 2, oops, a little mistake there, 2 times 5, which I know is 10, times 17, right? That's definitely a lot easier. I know 2 times 5 is 10, times 17 is 170. And that's exactly what this would be, and that's what that would be. I would just much rather multiply it in this order. So that's the purpose of the commutative property. I remember this one because I like to think about how, in a way, the numbers here are commuting, right? When I commute to work, I drive to work, so I kind of change my location. So the 2 didn't change in this way per se, but the 17 moved here and the 5 moved here, right? And then we ended up getting this. So I like to think of it as the numbers are commuting or moving around, okay? The next property is the associative property. So the way the associative property operates is that the numbers don't change order. So as you can see, if I just look at my letters here that represent numbers, so variables is the word that we could use to describe those. A times B times C, right? A times B times C. The order doesn't change, but what does change is the parentheses, right? You can see the parentheses are around A and B. Over here, the parentheses are around B and C. So let's get an example for that. So I'm going to say 2 times 5 times 17. so this is very similar to my last example, is equal to 2 times 5 times 17. So the order's staying the same, right? If I move the digits, the numbers around, if I move the numbers around, then it becomes the commutative property. Since this is the associative property, I like to think of it as changing which numbers are associating. So I see 5 and 17 over here hanging out. You know, maybe they're friends, they're associating with each other. Over here, maybe just the 2 and the 5 are hanging out, associating with each other. And I would solve these first because they're in parentheses, which makes kind of more sense, because if I do 2 times, so I'll pause and go, okay, 5 times 17, do I know that really quick? Not so quick. So it's easier if I solve these first and go, okay, 10 times 17. Okay, that's much easier. So the associative property changes where the parentheses go, which in turn also changes maybe which part of the equation you solve first, because you always solve in parentheses first. So that's the associative property. Okay, now the last one, and probably the trickiest one for people to really get, is the distributive property. Okay. Also, just throwing it out there, if you want to read these definitions and not try to read over me talking, you could just pause the video, read the definitions, and then go back to watching, right? So if you haven't done that yet, feel free to watch the video again and do that. So the distributive property takes numbers, so I'm just going to go straight for our example here. So I'm going to say 5 times then 10 plus 7 equals. Now what the distributive property does is this. The distributive property I like to think of as it distributes the numbers. So I take this apart and I go, okay, well 5 times 10 and 5 times 7. So I'd go, okay, well, I go over here and go 5 times 10 plus 5 times 7. Okay, they did not put parentheses up here. In class we have been, just to keep things clear right now for what we're doing. So you can see I distributed the 5, right? Even I have 2 5s over here, and it doesn't change the equation. This is the same as 5 times 17, right? And all I did was I took the 17, right? I could say that. I could say 5 times 17, but I definitely don't want that. So what I did was I split up the 17. I go, okay, 5 times 10 plus 7. Still the same thing. I just split it up. And then what I'm going to do is, okay, 5 times 10 plus 5 times 7, right? And then I go, okay, without, you know, cracking out any kind of an algorithm or doing anything like that, I can just go, okay, 50, 35. And this is, once again, you're using it to your advantage, right? If you use this distributive property, you could actually do this mentally. That's the goal, is being able to do it mentally. I think that the distributive property is probably the property we use the most without thinking. Okay, I would get 85.